Everybody, it's Tyler here at Kettering Kickoff. Check in team number 2960, Automation Nation. By the way, I'm here with John and Griffin. And Automation Nation just set the high score here at Kettering Kickoff so far, so we're having a great event. And I can't wait to talk more about this team. Man, the aesthetics on this robot just look great. Very clean packaging. Of course, we're going to follow that whole cargo journey, talk about their climber coming up here on Behind the Bumpers.
First Updates Now is made possible by viewers like you and also the following sponsors. If you are a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com. Continue your excitement of robotics at Kettering University with their Combat Robotics team and First Center. Turn your robotics experience into a professional career. Find out more and get your application started at kettering.edu/apply.
John, let's start out with the cargo journey on your robot. Talk to me about starting with your intake, and then we'll follow that whole cargo path.
Hi. So this is our intake, and this is one of the aspects of the robot that I'm most proud of because it went through a ton of iterations. So first off, when we first designed it, this piece right here was one piece. And so our crazy driver would run into the wall a lot because, you know, he's just trying to drive as fast as possible. And so it would run to the wall, and the intake would cantilever all over the place. And these belts would pop off, and then we couldn't play the rest of our match. So what we did was we added this joint right here and put these surgical tubing bits on there so it can flex, and we can continue playing our matches while running into walls. So Talia, if you want to put the down here. So as you can see, we had our intake, suck it in over the bumper intake. Then we have this indexing system right here. And what's neat about this is that our indexer can hold one ball, and our intake can also hold one ball. So we can manipulate each one independently. So what that means is that we can be outtaking this ball into our shooting mechanism right here, and still have this ball inside our intake still. Then, once that ball's out of the way, we can cycle the next one in and be ready to shoot. Then finally is our shooter, and this is a PID-controlled shooter, and we rev up to RPM, and then it's fully automatic to outdex our balls from the indexing system, and hopefully make those 2-point shots.
Your indexing that you have is obviously very powerful. We just saw that demo, it just like zipped right in.
Yeah.
Was that initial concept to go that way, or how did you come up with having that much force to bring in a piece of cargo?
So what we had was, whenever we slowed down the RPM on this, these balls don't really stick well to many different types of wheels. So you have to have all that force sucking the ball in and making sure that when you touch it, you own it.
From a packaging standpoint, your robot, it does look like, you know, your climber is kind of built around it. So when you're looking from your shooter, how did you determine that you were able to still shoot from that low of an exit spot on your robot and still be effective?
So what we did was these arms can actuate, and so once this is all in package, this will be up, and our bar will be back, or this bar will be back farther, and that makes sure that it is clear from our ball's trajectory.
Where do you guys like to shoot from on the field? What's kind of like your sweet spot for Automation Nation?
So our sweet spot is right along the edge of the tarmac, along that hexagon outside the goal. And in our last match, we had a very high accuracy, and so that was really good to see. And I really attribute that to our PID control. We spent a lot of time fine-tuning that so that we can shoot with accuracy. Because even though the goal looks really big, it's a really small range of RPM that you can be shooting at to enter or to be that accurate.
Let's pass it over to Griffin, who's going to talk about your climbing mechanism and that process on there, and we'll show off a bit more on how that exactly works in your robot. So let's hear more about what's gone into it, and if we can demo any of it too, it'd be great.
Thank you, John. So a few of the things that we really like about our intake is the fact that it sort of resembles a pull-up. So we're able to, from the ground, come up to the second bar, raise ourselves up, and then we have our rear lockers. One of the biggest things that we ran into was we weren't able to tell when our arm was closed. So one way that we solved that was with little switches, but those kept breaking after each match. So we switched to this photo eye, and since then, we have never had a problem.
Looks like you have a little bit of automation in your climb process as well, too. Talk to me about that.
John, our programmer, he's been very diligently programming and testing different speeds and actuation points. As you can see, we have a lot of wear, but nothing's perfect.
And then I'll ask kind of a question from this sort of packaging with the climber on here. Like, what came first from a priority standpoint? Was the climber designed of being like this big and then the robot's built around it, or did you build the climber around the robot?
We first built the climber because we felt that was the best way to get points during this competition. And after that, we were able to plan our shooting and indexing system.
Well, Automation Nation, thank you so much for taking time to tell us about your robot. Looking great here at Kettering Kickoff, of course, but can't wait to see future years' robots as well, too. Thanks a lot for taking the time.
Thank you. We're looking forward to see you next year, too.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Continue your excitement of robotics at Kettering University with their Combat Robotics team and First Center. Turn your robotics experience into a professional career. Find out more and get your application started at kettering.edu/apply. If you're a college student or recent graduate looking for an incredible internship, take a look at Stryker. Stryker provides a housing stipend, great pay, and an opportunity to work with state-of-the-art medical technology equipment. Discover why so many First alumni are coming to Stryker for their internship or career at careers.stryker.com.